In section 10.3, we deal with graphing and writing the equations of circles centered at the origin, and then we'll also do a portion of 10.6 when they're centered other than the origin. And the basic form of a circle is this: x squared plus y squared equals r squared, where r is the radius of the circle. So when we're centered at the origin, the key is finding the radius and then graphing out from the distance of the radius out from the center. So in this case, I know that x squared plus y squared equals r squared. So r squared is equal to 9. R then will be equal to 3. So if I want to graph this, I'm centered at the origin, and I want to move 3 units away from the origin, up and down and right and left, and then I've got my circle. Okay, so the circles are actually probably the easiest of all of these to graph because they're very consistent and they're symmetrical. So again, if I want to graph this, I can see that r squared is equal to 49. So r then will be equal to 7. I'll go up 7, right 7, down 7, and left 7. And we've got 4 points here that we can use for our circle. That's pretty close there, a little bigger. And there you go. Okay, now if we want to, sometimes we'll have a circle that presents the equation in a slightly different form. The key here is I have to get rid of the coefficients. There are no coefficients in the circle form. And you'll know that if these coefficients are the same number, I can get rid of all the coefficients by dividing by that number. So if I divide everything by 5, I'll get x squared plus y squared equals 16. R squared then is equal to 16, so r will be equal to 4. If I go up 4, I go down 4, I go right 4, and I go left 4, then that graphs my circle. Looked a little too big, I think. Yeah, a bit too big, so drop that down. And there we go. Okay, now writing the equation then is really similar. I have my radius supplied in this case. When I'm centered at the origin, it's very simple. X squared plus y squared equals 9 squared. So x squared plus y squared equals 81. No need to be concerned if they give you the radius as a radical, because you're going to square it anyway. X squared plus y squared equals radical 30 squared. So in this case, x squared plus y squared equals 30. Okay, so very simple. Find the r and plug it into the equation. A little more complicated is when they give me a point on the circle. But remember, if I have a center at 0, 0, and I've got a circle, and they give me a point at -6, 4, what I need to find is the radius. So all I need to do is find the distance between my 2 points, and I've got the radius. So my distance will be equal to the square root of the difference between the x-coordinates, -6 minus 0 squared, plus the y-coordinates, 4 minus 0 squared. -6 squared is 36. 4 squared is 16. So my radius, which is the distance, is going to be equal to the square root of 52. Again, no worries that this is a root. When I write the equation, x squared plus y squared equals root 52 squared. So x squared plus y squared equals 52. A tangent line. Now the idea of a tangent line is you've got a circle, you've got a point on the circle, and a tangent line is going to touch the circle in a single point. One characteristic of tangent lines is they are always perpendicular to the radius. So this is similar to when we were working on perpendicular bisector in the last section. So if we want to go ahead and write the equation of this, if I find the equation of, or the slope of the radius going to the point 2, 1, then I can use that slope to find the slope of the tangent line, and with the slope and a point I can use point slope, y minus y1 equals m times x minus x1. I can use this to write the equation of the tangent line. So first I want to find the slope. It's very easy when we're going between our 2 points. When 0, 0 is one of the points. So 1 minus 0 is 1. And 2 minus 0. So my slope is going to be 1/2. That's for the radius, the slope of the radius. The slope of the tangent line then will be the negative reciprocal of that, which will be -2. And now I can take the point and the slope and put them into point slope. Y minus 1 equals -2 times x minus 2. Y minus 1 is equal to -2x plus 4. And when we add 1, y is equal to -2x plus 5. That's the equation of my tangent line. When we work with standard form of a circle, again you see h comes in to be with x being squared, k comes in to be with y. That's been true of all the forms we've been working on. And so it's x minus h squared plus y minus k squared is equal to r squared. So what I need to find is my center, which will be at h, k. And once I find my center, I can move by my radius, right, the square root of this number, from the center in all 4 directions to create my circle. So my h in this case is equal to 6, k is equal to 2, so my center is at 6, 2. My radius squared is equal to 4, so my radius will be equal to 2. So now I'm going to take my center and my radius, and I can go ahead and I can graph this. So my center again was at 6, 2, 1, 2, 3, 4, 5, 6, 1, 2. There's my center, 6, 2, that's my center. My radius was 2. So from the center I'm going to move up 2, I'm going to move down 2, I'm going to move left 2, and I'm going to move right 2. And that's what's going to define my circle. And this is a little large. That looks about right. And there we go. That's the graph of our circle, not centered at 0, 0. So not much different. The key is locating the center, and then you're still using the radius up, down, right, left to create enough points to define your circle. If I want to write the equation of a circle, I can take this information and I can also plug it into the formula, which is, of course, x minus h squared plus y minus k squared equals r squared. So in this particular problem, h is equal to -4, k is equal to 2, that comes out of my center. My radius is equal to 3, and I just plug these values in. X minus -4 is x plus 4 squared. Y minus k, y minus 2 squared, equals r squared, which is 3 squared, or 9. And there I've got my equation of a circle. Okay, so circles, again, are probably the easiest to graph. And from here, we'll move on to work with ellipses.